Thank you for that introduction, James. I see a few familiar faces around the room. For those of y'all who don't know me, I'm Matt Foster. I started as the new sugarcane weed scientist back in July. Originally from Concordia Parish. I was the corn and cotton specialist with the AgCenter for around 3 years. I've got some pretty big shoes to fill, following in the footsteps of Dr. Jim Griffin and Dr. Al Ogeron, but I wear a size 13, so I think I'll be okay. So today I'm going to talk a little bit about herbicide resistance. That seems to be a hot topic anytime, I'm talking on the turn road with farmers. Headland, yeah, oh, that's right. So weed resistance to herbicides. What is weed resistance? So it is the inherited ability of some weed biotypes in a given population to survive and reproduce after exposure to a herbicide treatment that would normally control that population. Herbicide-resistant weeds occur naturally at low levels in the population, and when exposed to that herbicide year after year, the population shifts so that resistant population becomes dominant. So as you can see here in this little figure, all the green are susceptible. Say this is your first year. You got two bluish that are resistant at low levels. Spray it with the same herbicide this year, spray it with the same herbicide next year, so you have more of that resistant population. Then it shifts to more of that resistant population year after year of using that same herbicide product. So, development of resistance within a population. As I mentioned earlier, selection pressure from herbicides. On the x-axis, you have years of selection pressure. On the y-axis, you have percent resistance in the population. As you can see, around 4 years, it starts to increase. Typical awareness of growers is generally around that 40%. So if resistance is out there, you just don't know it. You typically, notice it around 40%. Or, I'd like to catch it as soon as possible. So that's why it's very important to scout your fields, document if you're seeing any failures, and go from there. So herbicide site of action, this refers to the biochemical mechanism by which a herbicide causes growth to cease in a plant. There's different types of resistance. Single resistance, so that's where a weed is resistant to only one family of herbicide or one mode of action. For instance, water hemp resistance to glyphosate, Roundup. Cross resistance, this is when a weed is resistant to one or more families of herbicides that belong to the same mode of action. So water hemp resistant to your SUs and your EMIs, so both of those are ALS mode of action, so that would be a cross resistance example. Multiple resistance, this is when a weed is resistant to at least two families of herbicides that belong to at least two modes of action. So water hemp, that's resistant to pursuit, which is ALS, or Roundup. You don't want multiple resistance. So a little bit about mechanisms of resistance. Target site resistance, you have that target site can be altered. So essentially the herbicide no longer binds to that site of action and cannot be phytotoxic to the plant. This can occur as a point mutation in the DNA by gene amplification and increased gene expression. And I'll show here, in Palmer amaranth, this is some work done by Dr. Prashant Jha. He's a weed scientist at LSU, and this was done in 2015. If you look here at the bottom figure, you have your susceptible population here, glyphosate resistant population. So Roundup resistant Palmer has 5 to 160 times copies of that EPSPS gene than the susceptible biotype. So this is an example of a target site overexpression. Non-target site. So this often gets a little more complicated as there are more mechanisms. So enhanced metabolism, the weed's able to break down that product, reduce translocation, sequestration, like in the vacuole of the plant, reduced absorption. One thing to note is this can provide resistance to herbicides which the weed has not been exposed to previously. So for instance, some work done back in 2011 on giant ragweed, rapid necrosis of the leaves when contacted by Roundup, they started to become necrotic, reduce translocation to the growing point. So this would be an example of a non-target site. So this graph here, this is the chronological increase in resistant weeds globally. I don't know about y'all, but I don't like the way that looks. It's steadily on the rise. This is from 1950 to 2020. It's not updated to 2023, but I'm about to show the current numbers. And this is the number of unique cases, so your weed species by that specific site of action. So currently, these are our most up-to-date numbers. Worldwide, there's 530 unique cases, species by site of action, of herbicide-resistant weeds globally, with 272 species, 155 which are dicots, 117 which are monocots. So here we have a chronological increase in resistant weeds globally. You have your species, number of species here on the y-axis, and your year on the x-axis from 1950 to 2025. So it's as you can see here, the red, that's ALS. You know, that's a pretty common mode of action that resistance occurs to. Here you have your triazines. Here you can see glyphosate in this darker purple. Again, I don't like this trend either, but it's the reality we live in. An old farmer used to say, the weeds always win. Mother Nature is going to find a way to overcome whatever we can put at it. So weeds have evolved resistance to 21 of the 31 known herbicide sites of action. And again, this is globally, and to 168 different herbicides. So these are the resistant species by site of action, the top 15. So ranging from 5 all the way to 12 site of actions, number of sites of action. And I have a few highlighted in red, as you can see here. I want y'all to remember this one. The Leucine indica, that's goosegrass. Lowly and perenni, multiflorum, that's Italian ryegrass. Conocloa colonna, remember that one, that's jungle rice. So remember goosegrass, ryegrass, and jungle rice. So I'm going to talk about that later. So herbicide-resistant weeds documented in Louisiana. There are currently 9 documented with multiple, that are resistant to multiple herbicides. In 2022, Dr. Ogeron documented paraquat-resistant ryegrass, confirmed in the sugarcane growing region. And in 2023, Dr. Ali Wright confirmed resistance of Italian ryegrass to photosystem 2 inhibitors, atrazine, metribuzin, and diuron. However, Turbosil controlled all those populations. So one interesting fact is I did a lot of work in North Louisiana with cotton and corn, and ryegrass is a major issue up there. So the populations in North Louisiana are resistant to Roundup, but they're still controlled by paraquat. However, these populations down here are resistant to paraquat, but they're still controlled by Roundup. So quite interesting. And I have a few weeds highlighted in red. As I mentioned, Italian ryegrass, itchgrass. Dr. Alley mentioned that earlier, resistant to fusillade, that was documented in a soybean field in Point Copique Parish. Palmer amaranth, I have a funny story. I mentioned I was from Concordia Parish. Back in 2010, I actually dug up those plants. I was an intern with the local county agent, and I still remember the field. It was around Lake St. John. The weeds were under a power line, so they thought it was a miss by the plane. They missed it. So turned out it was resistant to glyphosate. That was the first documented case in Louisiana. So what are some alternative chemistries for controlling paraquat-resistant ryegrass? Pre-emerge, clomazone's great on ryegrass. Esmatolicol, that's your dual products. Alion's a newly labeled product. I think it was labeled back in 21. Can be applied. However, read and follow the label. I think it states something on there about not being able to go over the top of green cane. It's going to provide good ryegrass control. I'm looking at a product, Zidua, which is pyroxasulfone, same mode of action as dual. Looking at that product, and it provides excellent ryegrass control as well. Post-emerge, as I mentioned earlier, glyphosate is still effective on these ryegrass species that we have here. Clethodim. In crop, we've recommended Invoke in combination with Agilox plus NIS or crop oil. But I believe Al did document some partial control failures using that. So, be mindful of that. If you suspect you have paraquat-resistant ryegrass. So, when I started back in July, the phone started ringing. So during the summer, I collected suspected resistant. I told y'all to remember this: jungle rice and goosegrass. They were in the top 15 earlier. From fallow fields. So the picture to the left here was a picture sent to me by a good friend of mine, Stephen Semino in Napoleonville back in 21. It's a goosegrass plant that wasn't controlled with glyphosate. Jungle rice, this was collected in 2023. As you can see here, you have a green plant next to dead plants. Pretty telltale sign of resistance. So that's suspected. We're working on trying to confirm that. This goosegrass was collected in White Castle, same scenario. Everything else in the field was controlled. All that was left were these weed species. They survived 2 applications of glyphosate, I think at 2 quarts per application. So recently in China, in sugarcane in China, multiple herbicide resistance in goosegrass from sugarcane fields in China was documented. Populations were resistant to diuron, atrazine, diquat, paraquat, and glyphosate. I'm not even sure if diesel fuel would kill those. So they can keep that in China. We don't want it here. So what do you do to manage those grassy weeds in the fallow ground? Some alternatives to Roundup. I mean, you can tank mix these products with the glyphosate. We haven't seen any antagonistic effects through my work and other weed scientists' work at LSU. Select, Post, Fusilade. Keep in mind they do have plant bat restrictions to plant for sugarcane. So one thing to note, there is some antagonism with some broadleaf products, 2,4-D dicamba, when you apply these graminicides. So a good rule of thumb is to apply the graminicide 3 days before applying your broadleaf herbicides or 7 days after. And one thing to note in cane, so if you have some of these weeds, in the fallow right before you plant, most pre-emerge products that we use at planting has activity on the goosegrass and the jungle rice. So your Command, Syncor, Prowl, it's going to have activity on those weed species. So how do we investigate resistance? So those particular plants, they weren't setting a lot of seed at the time, so I potted them up. I carry pots and potting soil and shovels in my truck, so I'm always, ready to collect weeds on the go. We collect the plants, grow them out, collect seed, grow the seed out in the greenhouse, and evaluate herbicide response in the controlled environment. This is currently being conducted at LSU in collaboration with Dr. Prashant Jha. He's a weed scientist on campus in the School of Plant, Environmental, and Soil Sciences. So I'm anxious to see the results from this study. So, is resistance always the culprit? I mean, just a few things that I like to consider. I'm sure I've missed a few things, but these are things I think about when I go to a field to evaluate a potential resistance complaint. Did you properly identify the weed spectrum in the field? Was the correct product used for that weed spectrum? Proper idea of that weed spectrum in developing a weed management plan is critical. You want to pick the right product based on what you have in the field. Was the correct rate, timing? Was a surfactant needed? Did you mix a surfactant with it? Correct nozzles. I have a funny nozzle story. So I was Dr. Jim Griffin's last student, and we applied a harvest aid trial on soybean. 7 days after, Doc went to the field to go rate it, and he called me. He said, "Did y'all put the chemical in the tank?" He said, "It's not showing any, we sprayed paraquat." I said, "Yeah, we mixed it up and everything." Well, he gets to scratching his head. He said, "What nozzles did we use?" We had some very coarse droplet nozzles. With anybody that sprayed paraquat knows it's a contact product, so coverage is essential. So you couldn't even tell on those soybean plants where you'd sprayed paraquat because of so I'll never forget that. Environmental conditions, soil conditions. I've seen over the years, if you put out a pre and it's real cloddy, you get decreased control if the ground is real cloddy. So that's something to keep in mind. Stress weeds. I went out to a call a couple years ago in North Louisiana. Guy put out Roundup and just wasn't getting any control on weeds that normally, it would. I mean, the whole field. It wasn't kind of like some are dead, some are not. So they were drought stressed. So if they're stressed and not actively growing, they're not going to take that product up. So that's one thing to consider. Bad batch of chemical. It does happen from time to time. Hard water. Some herbicides are sensitive to hard water. Weed size. That's another thing to consider. Smaller the weed, easier it is to control. And as I mentioned earlier, some products have antagonism when you tank mix them with each other. So this is a resistant risk assessment chart put out by the Herbicide-Resistant Action Committee. So you essentially have your management option here, and you can go across this chart to see if you're at low risk or high risk for resistance. So your herbicide mix or rotation. So if you incorporate more than 2 modes of action, you're at low risk. However, if you're at 1 mode of action, high risk, and so on. Cropping system, full rotation, and no cane. That's going to be a little bit difficult. Some guys grow soybeans, some don't. Weed infestation, control in the last 3 years. Just a few things to check off the list when you're considering resistance. So, weed resistance. We can't just rely on chemicals, guys. Like, it has to be an integrated approach. Mechanical, chemical, cultural, prevention, clean your equipment, sanitation. I'm a big fan of the harvest groups. I think they're great, but that could, in my opinion, that could be a potential source of spreading weeds if that equipment is not cleaned, from farm to farm or field to field. So integrated weed management is an approach to managing weeds using multiple control tactics such as cultural, chemical, and mechanical. Why is it needed? Over reliance of herbicides, herbicide-resistant weeds. Some factors to consider is your target weed species, your time, resources, and money. What's it going to cost to implement, alternative management strategies. Some components of that prevention: avoid contaminated inputs. If you're cutting cane for seed, if it's a weedy field, that's something to keep in mind, that you could spread weeds from that field you cut for seed and then plant. Clean your equipment, your planters, your combines. Just be aware of weedy fields. Prevent weeds from going to seed in the fields, ditches, headlands. Scout fields regularly and understand the biology of the weed. That's very important. Use caution when purchasing used equipment. So a funny story, I'm friends with the guys that farm soybeans here on Highway 30 between Baton Rouge and St. Gabriel. They own an equipment place in Woodville, Mississippi. Well, they bought a combine from Arkansas. Then they had Roundup resistant Palmer spread down here, all in the soybean fields, strictly from that combine. Never had a problem before till they got that combine. So something to keep in mind, it does happen. Cultural can be crop rotation, utilizing cover crops, variety selection, getting a variety that shades more, planting date. As I mentioned earlier, and I know I've mentioned this several times, scouting and proper weed ID is critical. Knowing what you have in your field, proper herbicide selection, using the right product, right rate, and right timing. Use multiple herbicides with multiple sites of action. Mechanical, don't be afraid to break out the old plow. Cold steel, not a lot gets through cold steel. Burning, hand removal, mowing, harvest weed seed control. So this is a chart from Dr. Prashant Jha. You can have percent resistance from 0 to 100. Years after introduction of a herbicide. Continuous use of one herbicide. You can see just peaks, just a linear increase. When you rotate chemistries, it buys you a little more time, stair-step effect, just rotating. But however, when you tank mix products, I'd rather be tank mixing products with multiple sites of action. Again, this is not, saying just to rely on tank mixing. You need to integrate other weed management tools, but it's pretty interesting to see. So to wrap up, some weed management strategies. Use residual herbicides as much as you can, guys. Timing is key. Rotate to different crops. I know that's hard in cane, but I would put that in for the soybean guys in the room. Rotate herbicides with different modes of action. Tank mix when you can at full rates. Don't cut rates. That's key. I know it's expensive, but stay at full recommended rates. Avoid sequential applications of the same herbicide. Use tillage, cultivation, and other cultural practices. Clean equipment. A friend of mine has a turf business, and I don't think a lot of people do this. He cleans his equipment between yards to keep from spreading weeds into clients' yards. So it's one thing that can help. Prevention is key. Control weeds on the headlands. See, I got it right there. I didn't put turn row. And ditch banks. Scout for and remove escapes. Have a zero tolerance policy. If you see a weed out there, get out the truck, dig it up, burn it. Take it away from the field. You don't want that stuff going to seed. If resistant weeds set seed, they can be a problem for years to come. Prevention is key. So some recent news I saw yesterday. This is for the soybean and cotton growers in the room. I don't know if there's only cotton and cane grower I know is George, and I don't know if he's here. But a federal court in Arizona vacated the registration of dicamba for over-the-top use in dicamba-resistant soybean and cotton. This had nothing to do with cane, but I just wanted to mention it for the guys who grow soybeans. So no more XtendiMax use in soybean or cotton, Tavium, Ingenia. So I'd like to thank the league for funding my research. I'd like to thank Dr. Allie Wright, Dr. Prashant Jha, producers, extension agents, crop consultants, Sugar Research Station staff, Mr. Warner Simon. And with that, I'd like to take any questions. If y'all think y'all got resistance, call your local extension agent, call me, call Allie. We want